Today about web applications. Unfortunately, my slides are in Russian, but they're mostly pictures, so don't worry if you don't understand them. I'll explain what I put there. And we will be talking specifically about how to write web applications that are quite complex, right? So I have here like a basic hierarchy of needs of web applications. At the bottom layer, we have static sites where like simple HTML pages, nothing fancy. And the next layer is dynamic UIs, which something like jQuery, animated buttons on clicks and event handlers, something like that. Some real basic stuff. These are layers of websites, right? We usually call that not applications, but websites. As you get higher, things start to get more interesting, and the stuff you see in your browser starts to look more like actual application. So we have optimistic UIs on top of that. So when you do stuff like do changes to applications, they apply immediately, but get synced to a server in background. So for example, something like Twitter likes or Facebook likes, when you like something, you see the effect immediately, no matter if you have connection or not. These are not exactly web applications, they are somewhere in between websites and web applications. And we have reactive applications, and which use server push to deliver data for you without you explicitly asking. We have applications that work offline, and we have collaboration when multiple people can work in the same application and see the changes of each other and do stuff together. So this is basic pyramid of complexity, as I call it, and the idea for us here is to try to climb to the top of it and to see how we can get there today. Okay, so yeah, and so the talk is structured in chapters, and as we get higher and higher, each layer is more or less optional. So if you don't need collaboration, for example, you can stop just before. It doesn't mean that you have to apply everything I will be talking today. You can only apply what you need and ignore the rest. So, but yeah, the structure is it will get more and more complex as we go. This is based on my experience of building web application. I'm working at the company called Cognition. And we're building a platform for coaching and training and learning. So we have web application that looks like that. It's more or less resembles a chat or something like that. It works in a browser. On mobiles, it works inside the browser as well. And we have all these modern features that I described here, more or less, except maybe collaboration. We don't have it yet, but we plan for it as well. And yeah, there's a lot of dynamics is this UI and so on. This is the stack we use, and so yeah, it's Datomic, Clojure, ClojureScript, DataScript, RAM, and React.js. RAM is based on React.js, but my point here is not to talk about stack. So disclaimer for this talk is that it will be quite a high-level overview, like bird's eye view on the architecture we arrived at without any specific details. And I have two reasons for that. One is I believe that we don't have enough of such talks, lectures about the high-level overview. We have a lot of great talks when people explain how to get some small details perfect, like how to use this library and how not to do this small thing. But we, in my opinion, don't have enough talks about how to structure the whole application. Like where do I put all the pieces? So that's one reason number one. And reason number two is that this stuff is fairly new, and there is not much yet to say about it. So I wish I could say, like, here's library X, you use it that way, and you get everything you need. But it's not that. So there are not enough solution that covers you, that you can take off the shelf. So because of that, I just can't dive into deep details. We have a lot of custom code written for support something like that. But my point is, if you understand the idea, it would be good for the future. In the future, if such a library would be written, you will know how to use it, why it works, and something like that. So, generic idea, no details, no Clojure or ClojureScript details here. And I want to start, so this is chapter 0. I want to start with something really basic, so we have like common ground to build upon, right? So try to imagine the most simple web application possible, right? So in my mind, it's something that does everything it does in the user interface codes. For example, even if it uses React.js or jQuery, it doesn't matter. So it does everything like interactions, listening for events, rendering, or changing DOM, and talking to the server inside the same, I don't know, place, inside the same method. We used to write code like this in jQuery and in the early days, and this is quite fine. So we have a user pocket at the interface. We have a server and synchronization here, and this is quite fine for simple enough applications. If it's not too big, if it's not too complex, it works fine, okay? And as I said, yeah, there are layers, and if you don't need anything more complex, I'm not advising against it. If it works for you, it's fine. But we will be trying to explore how to make things nicer so that our architecture scales. And the first thing we can do is to extract data model from the user interface, right? So basically, the idea here is that we have user interface code and we have data model, which is a separate piece of code, I don't know, functions, data structures that are not exactly tied together, right? So they're kind of separate. They depend on each other, but decoupled. And this is the simplest thing you can do, and the first probably thing you should do if the architecture where you put everything in a big ball of mud is not enough for you. The nice quality you get from there is that your code base becomes decoupled, right? And you can have, so the data model becomes a central piece of your architecture, and you can put other things, like here I have server synchronization and business logic. They also work with data model, and they don't know about each other, they don't care about each other. So user interface doesn't care how data model gets there, how it gets loaded from a server. It just assumes it is, right? And data synchronization doesn't care if what it gets from a server will be rendered or not. It's not important for it. And it's a nice quality to have in a code base because you can have these separate pieces. It's easier to analyze, to control them, to test them, and easier to rearrange them in the way you see fit. So data model, it's good. The next thing, the next question, I didn't mention how the data model should look like. And the answer is, yeah, the next thing we should do is normalize it. I want to give an example. So here is a sketch of the UI, which looks like a chat. It actually resembles what we have in our cognition application. So the blue user asks questions, and the green user answers them, right? So and he can put a couple of answers, he can skip some. Doesn't matter. So the first thing you can do, the simplest thing you can do is obviously when you're trying to model that into to invent data model for that is just to try to repeat the shape of the UI, right? So we have our question and answer, and answers are part of the questions kind of, and user is part of the answers. So we built a structure of nested JSONs of JSON objects and arrays. And it is fine, and it works okay, but the problem here is that it would work only okay for this exactly user interface, right? But if you have different one in your application, or if you have different users of your data model, it becomes harder for them to access it. For example, if I want to get a list of users from this data structure, it would be not impossible, but not natural and kind of awkward, right? So if you build your shape of your data around your user interface, you're locking yourself into decisions that everybody else would not be comfortable accessing your data. So a solution here is to use normalized data. So basically, you put everything flat, and you build links between the objects, or between the objects. And if you do that, you are not committing to one single way to access your data. You keep your options open, and this is a good thing to have at the beginning of your application, right? When you start building something, it might seem that your UI will always look like that, but in the future, who knows? Maybe not. Maybe you will have other use cases you couldn't envision that at that point. So at the beginning, it's better to keep your options open, and that's what normalizations brings to you. Chapter 3 is to use in-memory database for the model, right? Now, again, this is like, for some applications, having something like that, even kept as JSON objects, is fine. But if your application, for example, works with a lot of data, or the data access patterns are complex, it might be a good idea to use database. So now, I have a server-side background. I worked on backends for around 8 years, probably, before I came into front end. And backend people used to keep data in the databases, obviously, right? And we think that it happens because we need persistence on a server. And that's true. Yeah, of course, the first reason to use database is because we need persistence. But the second reason to use database is that it actually makes accessing data easier. It has a nice ways to access data. And there are powerful ways like queries, SQL queries, and indexes, and stuff like that. It's a good way to express complex, complex data needs in very concise and small natural language, which is already solved for you. I mean, you can take database, and it does a lot of good stuff, and it helps you work with your data and gives you a lot of nice properties, almost for free, right? If it's open source database, it's for free. And this is the motivation why we might need a database on a client. You might not need a persistence there, but accessing the data in more interesting ways than writing MapReduce or iterating through array is a good property. And it's a necessary property if we have a lot of data, for example, an array of hundreds of thousands of objects. It's probably, you will probably need indexes to search across that, and you probably don't want to write them yourself, and joins and range scans and stuff like that. So databases exist, and they bring all of that stuff for you. Except key value databases, of course. Key value databases doesn't make sense for me. And to recap, we have currently our architecture looks like this. We have a data model, which we assume is in-memory database, communicating with user interface, and we have user which, when he wants something to be done, he makes a transaction to the database, user interface updates, and that's how it works, right? This all happens on a client. There's no server here. And yeah, where is the server? Obviously, we need a way to communicate with the server, because most of applications do. And this is where we go to the chapter 4, synchronization. How do you fetch data from a server? How do you put data to a server from a client? Now, again, the traditional way to do that is to use request response approach, and like APIs that work in request response manner, even though they might have nice properties like on error handler and retries and stuff like that, but they always happen at the point of the you need data, and you call it the place where you need the data. It starts request and waits for response and tries to recover from errors if they happen. But yeah, and this is a nice model. It's really easy one to understand and to work with. And this is why most of the internet works like that, right? And it works really fine while the server is alive and responding in timely manner. And it works great. But servers are usually online, right? So the uptime is measured in 99 and something %. So usually servers are alive less than 1% of the time, which is kind of okay. But yeah, if you look at the data synchronization problem as a systemic one, what does the system of data synchronization? What are our needs? What we want? Which problem we want to solve? So there are a couple of problems. Like yeah, I have to now say this one. So this. The fullness, the timeliness, so responses should come in time, not later, not before. Coherence, reactivity, deduplication, and prioritization. So basically, usually a web applications have multiple requests in flight at any moment of time. And some of them might fail, some of them might not. Responses might come in a different order than requests were sent. They might, if you do a couple of requests, they might end up on different backend servers, and they might have different view of cache or database. And request response addresses none of these issues, right? So it's a really basic way to fetch data, and it doesn't work except for really simple case, or if you're okay with having your data sometimes broken, right? If something goes wrong, if server returns error, if server returns timeout, if responses get mixed from requests, you can get all bets are off, and you probably get your interface in a situation you didn't envision might happen, right? So it might end up in a state which is broken. So your only chance is to refresh the page, actually. This is why browsers still have a refresh button. So my point here is that synchronization is a serious process. It's a complicated process which you have to control. So there needs to be a central place that takes care of everything for you. This problem cannot be solved by using nice API like fetch API or something at the point of the data need. It has to be a system that understands the data it requests and which understands what's going on in all parts of your application. And but it's not actually a problem because the library can solve that for you. So the solution here is, as long as we have a data model on a client and on a server, is not to talk between client and the server through the REST API. Instead, we should let databases talk between themselves. And databases know about that they are synchronizing data. They can understand the meaning of the data. They can understand the structure of how data is stored. So they can usually do that much better than you can do through the REST API or GraphQL API or anything, right? So, and solutions like this exist. It's like the Firebase, PouchDB, and stuff like that. They are basically databases that can automatically synchronize your data. And they're nice, and they're fine. And this is a great way to build applications this is a great way to build applications. But I have one more point here, which is chapter 5, event log. So we don't stop at just having data model synchronized between themselves. We have an event log. So event log basically is a list of everything that happens in your application. Everything user does gets written as a event in a log, and event log produces a change to the database. So user never changes the database directly, the model, the database directly. It always goes through the event log. In the event log, you have obviously all the metadata about the event, and by implementing some function like translate the event into change, you can have like all the nice properties of log. Yeah. So yeah, it looks like that. Basically, what you have changed before that, user wrote directly to the databases. User actions have resulted in a change in the database. Now it goes through event log. Right. This is again. This is like not new, something new. This is called command query responsibility separation or event sourcing. It's a well-known pattern, and it is good because for these properties, so we have if we use event log, we get audit, we get analytics, so like for free almost. We can have corrections, like if we had mistake in our code, we still have a trail of events that led to the wrong data, and we fix the mistake, we can recalculate the data, right? So it's stuff like that is almost impossible to do if you only are keeping the last known state. You can have undo redo. Basically, if you need undo redo, you need some sort of event log anyways. But the real point why I'm talking about this here is because synchronization between events log is much simpler than between databases, and you get a lot of stuff out of it, and it's possible to implement it by yourself rather than like if you had to synchronize two databases, you better don't try to do it yourself, but event log is possible. So here's the schema. We have server, we have time, client, we have time flowing downwards, and imagine the user inserts a couple of events to the client, right? And what needs to happen, we need to synchronize these events to the server. Basically, it's kind of easy to do because you can associate something like numbers or counters to the events, and then it's really easy to implement a protocol that will check which events are new, which events are missing, and you will never get in a situation where, because of strange combination of events, you miss some event or you get some events twice. So stuff like that never happens in such systems. So you can implement them super correctly and never see like strange unreproducible bugs, right? But another nice property here is that, as you remember this slide, there is no server involved at any stage here, right? So we update the interface as a reaction to user's event without involving server at all. So as the drawn here, for some reason it's smaller. As you see here, we don't care if this event is not been synced yet. We can update the model just right away. And this is called lag compensation, right? So when you click like on Facebook, the like count increases immediately. It doesn't wait until it hears from the server. And this is a nice property to have for your application. And it's nice because lag is always present, right? So you always have some latency between server will respond. And here I have super scientific graph about the probability when the user thinks he's offline, depending on the time. So there's latency times in logarithmic scale, and around, for example, 10 seconds, user will probably think about I'm 50% being offline, 50% I still have to wait. And at this point, around 100 days, he decides I'm totally sure I'm offline. Yeah. So if something is bad with the server and events can get synced, it doesn't matter for a user. He still sees the user interface updating, and he still sees, everything is working. He can continue to build stuff, right? And this is called optimistic UI. So yeah, your application works, doesn't care. Now, if we explore other patterns that can happen here, so for example, we have some new events on the server which client misses, right? So we have to synchronize them them this way, and this is called like reactive UI, basically, or server push or something like that. Now, if we have another client here, and he is pushing data to that server, we can get these events here, and this is how you get collaboration, right? So just by looking at the same event log from 2 different browsers, you get collaboration almost for free. But there is a catch, of course. Yeah, here's always a catch, which is a conflict resolution. And I want to mention here that the conflicts will always be present no matter how advanced our tech will be, right? So there never will be a library that will say to you, you don't have to worry about conflicts. If some library doesn't mention conflicts or tells it takes care of them, it means you don't know how your conflicts are resolved, right? But you always will have conflicts, and you always will have a strategy for resolving them. You might know about it, you might don't know about it, but it always will be there. It might be good, it might be bad. If you don't know about it, it's probably bad. But yeah, so we have to deal with that always. And my point here is that event logs make handling that case easier. So here I have like an example of such situation we get ourselves into. So we have 2 different browsers, and they try to update the same text field with different values, right? So server must decide which one to use, and so you can't just so you will see like how data looks to server. It doesn't mean anything to the server. It probably doesn't mean anything to you as well. So server must decide which one to use. And the best way, so we have, if we have database synchronization here and here, the best way it can do is to arrive to some deterministic solution. It always has to be deterministic, but it probably won't be a smart one. So yeah, if you have events instead, it doesn't look that much different. Again, the problem is the same. But what changes here is that events has a metadata about its context, right? So it has something like timestamp what it happened. It has author, it has context in which it happened. It has intent, what you're trying to do when this event was generated. And it makes solving conflicts not necessarily easier, but you can make more meaningful decisions by utilizing this information. So for example, if we have updates from 2 different users, and one of the users is moderator of the, for example, it's forum, and the author changes the post, the moderator changes the post. We might prefer, you might have a policy that always prefers the changes from moderator first, right? Or if the author is the same, that would mean that the user changed the post from 2 different devices, and it means that we can use timestamp because he's probably the same person. He's probably aware that these changes weren't synchronized, but he did something later on, so he probably knows what he's doing, something like that. So my point is here, by using metadata on events, we can make more intelligent decisions. And this is an overview of the whole architecture as we have it now. So this is the cycle of what happens on a client. This is event log on a server. They get synchronized somehow. Yeah, and it's stored somewhere on the server. Doesn't really matter where. One more point I want to make is this chapter 6, server-side rendering. So server-side rendering is somewhat important for some applications, not for all of them. But if you're building mobile UI, usually if you're building applications, you usually don't care about the Google indexing, but you probably care about mobile performance. So it's still a problem even for web applications, right? So the idea here, this is a graph as we had it on a client, right? What happens if we try to run the same code on a server? So user interface will probably be gone. But instead of that, we can just generate HTML file, which makes sense on a server, and which is exactly what we need on a server, right? Data synchronization will probably be gone too. But instead, we have a direct access to the database. So a server can make direct queries to database, retrieve the model from there, and render HTML file instead. So this is an example how we can take the pieces we had split our our architecture into, reassemble them, take pieces that make sense on a client and reuse them on a server, right? And I am mostly I'm saying that because like if you have the because the terrible stories about when people, for example, try to run server-side renderer, but they found out that so here's a terrible story about when some person wrote some UI, but the rendering code was complected with data synchronization code, so they cannot just run the UI on a server as a React UI without actually running this data synchronization. So they were coupled together, and the problem was you are already on a server, but you have to make the request to yourself to get the data the usual way the browser gets it. So which is not natural, of course, but if we have nice little decomplected pieces, we can avoid that. So this is mostly the end of my talk. The summary. We have to make some conclusion. I'm not sure which one. So we talk about data model, normalization, in-memory database, synchronization, event log, and server-side rendering. And by using all that, we get to the top of the pyramid of needs of the web application. We can get most complex application written, even though we can't use really libraries. Well, we can use some libraries like Firebase or something like that, or we can write the code ourselves. And we can get there. The point is we can get there. And I will take questions right now. I have a little helper for you. Yes. Any questions? Yeah?